Okay, guys, so let's get started. So we'll again continue with Seaborn. So where we left yesterday. Okay, so let me run this Jupyter notebook one more time. Since I opened the Jupyter notebook just now, so I'll just run it and we'll move to the same location where we left. Okay, so yesterday we were doing this regression plot. Okay. So what is a regression? Okay, regression is a straight line on scatter plot. Okay. Uh, so let me run this first and then I'll explain it. Okay. So how will I create? I'll say SNS. Then I need to use IM. SNS dot 1 minute. Okay. M plot actually. IM PLOT. Okay. I don't know why it is not coming. Okay. Implot. Okay, and then I have to use x and y. Okay, so x-axis I'll take total bills. Okay, from a tips database. Okay, tips. Yesterday we were doing, right? Total bills. What is total bills? It's a column name. Total underscore bill. Okay, on x is your bottom, comma, y-axis I'll take tip. Okay, comma data. So data you have to give a reference. So what is your data there? It's a tips. Okay, if you recall, yesterday we were doing, right, tips, that one. Okay, and then I'll say plt dot show. Okay, so it says module Seaborn has no attribute implot. Hmm. Okay, okay, this is LM. Okay, not I. Okay, I typed incorrect. L, this one, first letter. Okay, now you see the plot has picked up the total bills. Okay, and tips. Okay, how much we paid. Now whatever the straight line that you see here, right, what it indicates is when your data points, whatever dots you see, these are all your data points. Okay, when these are very near to this straight line, right, so we say, you can see here. Okay, this is one, this is one, this is one, this is one. Okay, all these are data point and you can infer by seeing this is, so the minimum that users, I mean customers are coming and paying, the total bill is close to 9 and it ends 25. Okay, so it's a $9 to 25. Okay, you have to see this area thickness. Okay, thickness of your where you can see your dense area. Okay, so this is your dense area and this lines gives you the correction. Okay, sometimes if you are not sure, you can see here there is a gray, some area are grayed out here and here, right? Okay, so you can pick this also point. Okay, but not always. So most of the time you have to infer from this data is from $9 to 25 is what you can say in your this thing. Okay, so I'll now run the count plot. Okay, count plot you will come across most of the time, because if you have a categorical data, You need to count how many are, if you say, for example, if you have a gender tab or a gender column, you have male, female, right? You need to count. Okay, that is also one of the statistics that you can uh, uh, visualize. Okay, how do we do that? We'll see. Okay, count, plot. So again, this is very simple. SNS dot, press a tab and write count. Okay, so count plot is a function. I'll pick that. Okay, else I'll take x equals to. Okay, if you see that, if you see the okay, if you see the data here, okay, tips dot head, I have just typed it here to see which one should I take. Okay, I want to see the tips. Okay, sorry, this is a count, right? Sorry, categorical. So I want to see the day. Okay, so I want to count what are the days are there where people are coming most of the time, or frequency, or the frequency. Frequency is nothing but continuous people are coming. Okay, on which date? Sorry, which day, not date. Sorry. Okay, and we'll do the same for sex also. Okay, so first I'll take day, comma. Okay, now I have to specify the data. Okay, where is my data stored? It's in tips data folder. Okay, and then plt dot show. Okay, now you see, so generally when you use the count plot, you will get in a bar shape. Okay, now you see there is a gap, there is a gap, there is a gap. Okay, there are a lot of parameters that you can pass with a line and all those things. Okay, so you can refer to the documentation for count plot. If you can type sns dot count plot parameter. Okay, it will take you to the Seaborn count plot. Okay, here on the main page, so it talks about hist plot, bar plot, cat plot, okay, count plot, okay. So it takes the data, which is Titanic, and X is equal to class, okay. So how many people are from the first class? 200 and some 210 or 220, okay. Same thing here. Second class, how many people were there? Close to 199. Okay, and third class, you can see Janta, most of the Janta are there close to 490 or something close. Okay, so you can use, and these are all the, see, this is how you're going to learn. Okay, this is a data, this is your X class and survived. Okay, when you're comparing two, okay, you can do all these things. Always refer to documentation. Okay, if you need the percent, stats is equal to percent, you can say percent also. Okay, uh, yeah, this is the implant. See, the one which I just did. This is what I need. I want to tell you. This is the first statement. This is a syntax. You see how many parameters are there between this bracket and this? Data, X, none. Okay, and you have all the explanation at the bottom. Okay, so this is what I was telling. Always refer to the documentation part. Okay, when I'm teaching right here, some function you might not understand. Take your time, open it up and see. Okay, legend out is equal to none. Okay, if you say yes, what happens? You'll get a legend. Legend is equal to true. What is this legend feature? Okay, this is called a legend. On the right hand side, you see, right? Blue, amber, green. Okay, this is a legend. This is a legend. Okay, this is a comparison between two, male versus female. Okay, and they have also picked up from species. Okay, so same, what is that? Iris database is there, no? within inbuilt. Okay, I think they have big penguins. Okay, so so there's a pair plot you can see. Implant you can do multiple comparison. Okay, so when you um, sit and understand this graph, right, it will be very interesting. Very interesting. Why this data point is here? Okay, why this is here, why there is a dense. Okay, it is your data distribution. So how your data is scattered and how data is distributed across. So there are different ways. Okay, and this gives us some inference also that you can draw. Okay, coming back to this, so this is one way you can do. Okay, so we'll try x is equal to day. Now what we'll pick up is sex. Okay, now if in the sex column, if you have two values, male, female, okay, so you will get only two bar. Okay, you see how many males are there? Close to 85. Okay, or 90 you can say. Okay, and if you see from the sex column, you can draw inferences. We see most of the people who visited that hotel or restaurant, right, are majority of them are male. Okay, as per our data, it shows. So on an average, this is the data that it gives you the detailed numbers. Okay, I think we have one more, right? Time. Whether they are coming for lunch, dinner, and all also you can do. See, most of them are coming for dinner. Simple. Okay. See, right now, see, we have how many rows? Some 140 or I think 400 rows are there. What if you have million of rows? Okay. So you can do lot of inferences here. Okay. So lunch, very limited. Okay. And you can also check lunch time, what is the tip they are giving, and dinner time, what is the tip they are giving. Okay. That also you can validate here. So this is count plot. What was the next one in the PPT? Pair plot, we have done box plot, violin plots. Okay, so violin plot is also very simple. Okay, very simple. So how do you do it? Again, you have to call your variable, the alias which is SNS dot. I'll press tab and I'll type v, yeah, violin plot, the first one. Okay, and it's a function open and close. Okay, so here in violin plot, if you see the violin, right, you have a straight line, and on the right hand side you have some bulge, and on the left hand side violin, everybody know, right? Guitar. Okay, guitar also you can take an example. So guitar is like you have a straight line top to bottom. Right side you have a bulge where you can hold it and you can play, right? So you have to just think like that. Okay, I'll take x is equal to day, comma, uh, y is equal to total underscore bill. Okay, this is our one of the column there. Total bill, how much they paid. Total bill. Okay, comma, I'll take data. So data reference you have to give, it's a tips database. Okay, or folder that you are reading. Tips, and then split. Okay, in violin you have a straight line, right side and left side is there. So if you say split equals true, then it will split. Okay, we'll see. I'll remove this one. I'll show you the difference. Okay, so plt dot show. Okay, now you see this is like a violin. Okay, so split is equal to true. Okay, now you see here Thursday. Okay, so on Thursdays, okay, you see this bulge area. Okay, so this is your data points. Okay, and 1 minute, I'll just take a duplicate and I will say I'll remove this one. Okay, okay, yeah, this is like a violin. Okay, when you remove that split, right, so you get a bulge here and bulge here. Okay, now inside you see this is your box plot again. Okay, it takes a shape of box plot, and this white dot that you see, this is your median midpoint. Okay, so what is your midpoint? 10 to 20, close to the starting point is close to 19. Okay, 18 or 19. Okay, to the scale 18 or 19 or $15. Okay, and it increases. Okay, and it goes up to 21. Okay, so that is your data point. Okay, Thursday, Friday, Saturday, Sunday. Okay, now you see here what is this point resembles here. Okay, so this resembles the highest amount that they have paid on Saturday. Okay, it is close to 59 or something. Okay, you have to take a rough. Okay, 59. Or this one on Sundays, highest is close to $55. Okay, so that is where, so you have to understand, sit and understand why, what is this. Okay, what is this bulge means? Bulge indicates minimum bill was between 10 to 20, the bulge area. Okay, so this is what it reference gives you. On Thursday minimum was between 10 to 20, or you can say 10, 11, 12, or $13. Okay, this one is slightly down. Okay, Friday is little down, I think, little down, so you can say this was close to the bulge area. Okay, this area is bulge, right? So you can say minimum was $12 on Friday. Okay, most of the bills that the I mean customer paid is between 12 to $13. Okay, clear?
Yes, sir.
Okay, okay, now we'll just learn about the there's one more called grid sorry style. Okay, it's just a small thing that we should learn. SNS dot set underscore style. Okay, this is one function. Okay, when you add this at the top very beginning, okay, all your um, graphs, right, whatever visualization you are doing, it will take that style. Okay, so we have white grid and then we have dark grid. Okay, so I'll add dark grid. Okay, now you see inside, earlier it was like a white background. Now you see it has changed the color, right? So you can say dark grid. These are all called grids, lines. Okay. Sometimes for representation, you want to point where is this point between this, and all. Okay. Grids also you can add. Okay. It will apply wherever you have graphs and all, right? It will apply to all. So I forgot to introduce that at the beginning. Okay. So this is a style that you can create. Like in PPT, you have a style, right? A format that you follow in all the PPTs presentation. Similarly, there is also one of the set style helps you to apply that style for your entire visualization. So that is what it means. Okay. And there is one more. 1 minute. I'll take dark. I tried this before. Okay. Now you see this is dark. Okay. And even there is something called ticks, tick mark. Uh, where is a tick mark? No. Did I run this? 1 minute. Okay. Ticks is not working. Dark grid, white grid. Okay. I'll pick dark. And there is one more SMS dot uh, set underscore palette. Okay. In palette, I'll pass the parameter called uh, pastel. Okay. Now you see color has changed from before. Okay. Pastel color. Okay. Custom color also you can give. Okay. Always start with hash random number. Okay. Like I have already some number I'll give 6666 1 2 1 2 3 4 5 6. Okay, some random number. So not a valid. Okay. Okay. Color code we have to check. For now, I'll give some green. Green is also not there in palette name. Okay. So you can say 1 minute. I'll check here. Okay. So these are all the palettes you see. Color. Okay. So these are all the standards. Whichever you want to use as per your standard, you can use. Okay. So saturation. Okay. How do we choose? We should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10 colors. Okay, so whichever color you want to use, if you say, okay, then you can use. Okay, so you have essence dot color underscore palette tab 10. So this will be applied. Okay, something like this. Let me try this. I did long back. Okay, so these are tablet, green, red, purple, pink. Okay, so I'll add blue. Let me see. Blue. Okay, blue is not there. So pastel. Okay, you can see this color has light blue now. Okay, so there are different codes, guys. Okay, so you have to see this is pastel. This is called muted, bright, colorblind, deep, dark. Okay, saturation, luminates. So I can use HLS 8. So HUSL. Okay, I'll use bright and see. 1 minute. See, now it has changed bright. Okay, so this is the color code: color blind, muted, bright, then pastel, deep, dark. Okay, so there are a lot of color palettes are there. You can take some time to go through it and understand color. Okay, so one time if you do see, you will learn. Next time you don't have to go anywhere, right? You go to here and check whatever the color you need as per your standard or branding, right? So you can pick up those colors. It's very easy. Okay, so this is just an example. Okay, so these are some of the functions. You have to declare this at the very top. Okay, I forgot to do that. I'll just add it here. Okay, at the beginning. Okay, next one, what we'll do is title. Okay, we'll try the this one also. Where is the regression one? Okay, so this is a data set called iris. Okay, and I'm using a line plot here. Okay, and this is a sepal length. Sepal length is nothing but your one of the columns. Okay, and sepal width is numeric data type. So whenever you have numeric, you don't have to worry. You can use most of the visualization techniques to bring that up. Okay, so in SNS also, in Seaborn also, if you want to create a title, see right now you get only bottom and side. Okay, what if you want to give a title here at the top, and if you want to give some other titles, right? How do you do that? Okay, I'll use this box plot. Okay, X is equal to SNS dot box plot. X is equal to date tip, data is equal to tip. Same database I'm using, tips. Okay, and I'm just adding here AX, this reference, AX dot set title. Within braces you'll type your title, then X label, what you are showing on the X axis, and Y axis what you are showing. Okay, so here tip by days, weekdays, and tip amount. Okay, so on Sundays we don't have any outliers. Okay, these points that you see behind this uh, whisker, right? These are all called outliers. Okay, even on Thursdays we have outlier. So generally, if you see people who are spending, okay, tip amount. So on an average, they're giving to 2.3. Okay, $3 they're giving. Okay, so this midpoint is what you have to catch hold of it. Okay, and on Fridays for $3. Okay, and this one Saturdays it comes close to some $2.5. Okay, and here $3, three and above, $3.5 or whatever. Okay, $3 and cents on Sunday. This is on average. Clear? Okay. Okay. Now I'll add some summary. Uh, okay. So the summary talks about Seaborn is equal to, it's a combination of matplotlib plus statistics and beautiful defaults. Okay, so you can change your entire this thing, the entire Jupyter notebook with the same standard. Okay, but you have to declare at the very beginning at the top, okay, the color pattern or whichever style you want to use. Okay, and this works with pandas data frame. Okay, and these visualizations are suited for what? EDA. Okay, exploratory data analysis. This is what we're gonna start from next week. Okay, so we have one more session tomorrow, and you can also see the distribution visualization. Okay, so whatever you are seeing on Thursday, whatever the amount we have, we are seeing the distribution. You can even use the bar plot and hist plot, and then you can visualize. Okay, relationship plots. Okay, what is that? Pair plot. Yesterday we did it. Okay, correlation is your heat map. Okay, heat map correlation. Because you are using CORR here function to correlate your data. Okay, this is pair plot, pairing. Okay, so this is what we're gonna learn in this pattern. Let me see if I have missed anything. Okay, uh, recite plot, heat map, we have done. Cluster, let me check if I have done this. Okay, cluster, these are all relationship. Okay. Okay, we can, you can go to this documentation page and you can add this thing. Okay, so I already added one. I'll add one more data set here. SNS.load dataset penguins. Okay, so I'm running one command, sns.pairplot penguin. Okay, this is our data frame. Okay, so before that I need to run this. What is this data type and all, I need to understand, right? So I can say, okay, so this is my data. Okay, so we have some species in penguins. Okay, these are some names. These are the islands where these are found. Torgersen. Okay, and bill length in mm. Okay, so the length of these penguins. Okay, 39.1 meter. Okay, it is millimeter. Okay, and this is depth. Okay, And wherever you see NaN, these are all missing value. Okay, not a number. Then flapper. Okay, so like penguins, they have flapper, right? So what is the flapper length? 181 millimeter, and mass weight of this 3750. This is in grams. Okay, when you convert that into kg, you have to do the calculation. Okay, and what type of sex? Okay, male, whether that penguin was male. Okay, male was body mass is 3750. Okay, female is 3800, female 325. So on the average, if you see, female are all above 3000. Okay, male also 3000 only. This is a standard weight, I guess. Okay, so this is the pair plot that we are doing it. But see, just giving a plot will not work out. You need to understand. Okay, what is this? What is this? Okay, this is flipper length mm. Okay, so if you see here, we need to understand the data first. Okay, I just added this just for your reference purpose. Okay, you have this pair plot which we did it. Okay, and this is for penguin uh, histogram. Okay, hist. This also you can do. There are different ways that you can predict. Okay, now you see the color code and all the richness. Okay, it looks very good. It looks very good, and it gives you your legend also. Okay, there are three type of species: Gento, Chinstrap, and Adelie. Okay, so color, you can see the color representation. Blue means that, and this one means this. Okay, and Gento, you see, this is very, there is a separation here. What that means is, what is this? Bill depth. Okay, this is depth, this is length. Okay, now you see, in length also, if you see, this is represented here, this is represented here, and this is represented. What that shows is all these three species length, okay, differ from these three species. It's not same. But here, if you see the depth, okay, orange is what Chinstrap and Adelaide has the same almost matching size. That is what this pair plot shows. So you have to write the inferences there. Okay, this also. This is what top. This is body mass. Okay, so what is the body mass? You can see here at the top. So somewhere it is, some of them are of the same size. Okay, you see this area. Okay, so this is what it gives you the inference. You have to read a lot of this thing. Okay, same thing. Okay, and this is for KDE. Okay, there are different kinds. One is kind is equal to KDE. This is the format you're gonna get. And if you use hist, okay, hue is equal to species. This is what you're gonna get color. So different variations are there. Okay, in plotting also. So I'll just add it and I'm gonna share it today. So this will help you for your reference and all. Okay, you see here. Okay, I don't like this KD and all. I generally use this one species. Okay, and another one is histogram. Okay, so you see boxes. Okay, same data. So same data you can visualize differently also with a different features. Okay, this is a kind is equal to hist. Okay, hist means stands for histogram. Okay, and when it, you can see here. Okay, this is a boxes. See everywhere it is boxes. Okay, color code, different light color, dark blue, and all that is there. Okay, wherever it cannot do body mass and all. Okay, so it will give you in the normal histogram. Okay, guys, one more. We'll try one more. This is species penguin species marker. Okay, so here we are adding OSD markers. Okay, so this marker is OSD. For O is for this, S for this, and D for this. Okay, so you can see O is round. Okay, and this chin strap is like square, amber. Okay, differentiation basically if you when you're doing a differentiation, okay, to get a correct size, okay, size of the species here. Okay, now if you see here the length, which one is the lengthy here, you can see by this. Okay, which one is Adelie. Okay, these are most of the time are lengthy. Okay, the length of this species is what depicted here, and the mid one chin strap is most of them are average size. Okay, or this you can say above average. Okay, left side you have to see the legend and mass. Okay, body mass. So which one is again top? This one only. Adelie. Okay, that was this. Let me check the okay scatter plot. Same thing, whatever we have done, different ways are there using a properties inside you. If you use the properties, so you will get a different this one. Okay, I see. I mean, it's up to you, but see, all this will not work out for everything. Okay, so it depends on the data and all. Checking those, and let me check. This is a rug plot. Okay, doesn't look. I used this before, but I didn't like it. Okay, so when you are finding the inference on this data, right, it takes some time to understand. Okay, dist plot. Did we do dist plot? No. Okay, this is called cat plot. A category plot. Okay, so first, second, third. Okay, class. What is this? Titanic data. SNS dot load Titanic, and then you are doing a category. Okay, so third class you can see it's a highly dense. This is what I was telling, right? You just copy this. Just I'll add it at the end. Okay, okay. Now you see already we have seen the data. Just now I was going through it, right? Lunch, female, Titanic. Titanic also I did it a while ago. So who are okay? If you see first class, we have less dense. Okay, second class, okay, little. Okay, but if you see in third class, you can by seeing the dense here, this area, you can see most of them were traveling where from third class. Okay, in a Titanic ship, and you see highest ticket that they paid. This is box cat plot. Okay, cat plot. Okay, and you see here in third class, all these dot donates, we have a outliers. Okay, when you are doing any prediction, you have to clear this. Okay, so there are some models are there inbuilt in Python. where you will be doing that. Okay, so if you see the most of the age group in third class where this median, mean mode median, statistic imputation, you'll take this. So 25 years is average. Okay, and in second class 29 to 30. Okay, and first class 40 age. Okay, so this is how you have to draw your inference on the data. Okay, this is different view. See, this is a boxen. Okay, I've never tried this before. So whenever they release any new Python package, right? So you get to see all these things. You have to always refer this documentation page. See, this also looks good. Okay, now here this is a legend. If you see, it is between male and female. Okay, female. What was the average age? This line you have to catch 35. Okay, and male 40. Okay, first class, second class, third class. So third class was close to this, female were close to 20, 22, very engaged, and this one 25. This also you can infer. Okay, here you have to write your inference, and then you can read out your data storytelling when you are presenting in meetings and all. Same data, or you want to copy, take a screenshot, put it in your PPT, and I think you have an option to download, save and export as PDF. Okay, you can turn that as a PDF and then you can present. You have a lot of things, guys. Okay, see, this is also one of the cat plot in the shape of violin. Okay, kind is equal to violin. See, cat plot also you can use in violin, something like violin. Okay, these are all called data df, height, survived, kind is equal to bar type. And this is looking very funny. Okay, what is this kind? Where is kind? Kind is equal to violin. Okay, inner is equal to none. When you mention inner is equal to none, you will see a skeleton like this. Okay, inside. And here we didn't mention anything. Inner is equal to none, nothing, right? So it will give you the filled area. This area. Okay, so different ways are there, guys. Okay, when you get time, please practice. Okay, so I'll just add this as a reference so that you can. Okay, so I think we are on top of the hour. Okay, 9:32. Uh, okay, please practice this on weekend. Okay, the Matplotlib and Seaborn both. Okay, so whatever the see, we have done data with tips and other thing, right? What I want is, see, you have all this data. Okay, you can play around with any of them. Titanic. Okay, I have used tips and iris most of the cases. Okay, tips and iris is where here. Okay, you have mpg. What is this mpg? To be frank, I don't know. Mpg maybe, I think something to do with uh, okay, I'll say mpg equals sns dot load data set mpg dot head. Okay, I want to see what kind of data is this. So this is mpg. Okay, some values are there. Cylinders, displacement, horsepower. Okay, vehicles. Okay, name cars. Okay, I got it. Ford, Torino. Okay, some vehicles. Okay, got it. Okay, so different data sets are there for your learning here. Dots. What is this dot? I don't know. Diamond, it could be a shape, size. Okay. Shine. How many cuts are there and all that. Brain network, attention. Okay. So if you play with all this data, right, you'll definitely get some idea. Okay. I don't know what is this planet. Okay. I'll just add it here. I'll take a short from for planets is PNT. Planets. 1 minute. I'll say PLNT. Okay, so radial velocity, okay, and orbital, it has to do something with space, okay, number, mass, distance, year, okay. So you pick up whichever the data you like, right? Car crashes, where you can uh, identify, or exercise is there, flights is there, okay. Geyser, not geyser, geyser is there, glue is there. I don't know what is the data type. Health exp, okay, health exp or experience. So you have lot, you just play around with this data on weekend. Okay, tomorrow what we'll do is we will start statistics. Okay, so next week we will continue with statistics. Tomorrow we'll just have a basic introduction, and then Monday onwards we'll do some practice. Okay, so that's what we're gonna learn. I'm gonna share this now. Just give me a minute. I'll share this. Please save this file. What is called Seaborn Library. Okay, whatever file I'm sharing, right, you keep it in your G drive, personal. Okay, create a heading called Python. Okay, under that Python, you can have a subcategory of folders like visualization. And then initially we learned about basics. Then we learned about data structure. Okay, tuple, set, dictionary and all, right, all those things, right? So you can make a respective folder and put all these things there in a proper, so whenever you want to refer, you just open in Anaconda editor, and then you can go through it and practice it. Okay, it comes by practice only, guys. Okay, so daily I'll do 1 hour practice, whatever the data set, or if I see something new here, I'll do the practice. Okay, so there's a dark palette. You have a sea green. See these names if you need. This is the hash code I was talking about. Okay, color code hash 79C something. Yes, here. I'll just maximize this page. Okay, this one. So when you add this, it will turn your entire this thing into some of these colors. Okay, color code and other things are there which will enhance your visuals. Chalo guys, I think we are on top of the hour. I've shared this. Okay. We will meet again tomorrow 8:30, and tomorrow will be statistics. Okay. When we get into EDA exploratory data analysis, that is